What are you looking for?
Can you hear us?
I tried on.
Good. All right.
Thank you.
Okay. Thank you all for joining us, both everyone here and everyone virtually. Woo! Let's make some noise to make sure people at home know how cool we are. Okay. This is the Full Stack Data Science Meetup. This is a group dedicated to exploring the intersection of data science and full stack development. We aim to cultivate a space where professionals, enthusiasts, and learners alike can come together to deep dive into the multifaceted role of building machine learning applications, including machine learning engineering, machine learning operations, data ops, data engineering, application development, software engineering, DevOps, and high-performance data science practices. Yeah.
Good conduct. In short, we want everyone here to feel welcome. If anything happens that does not contribute to that, or if you have ideas for how we can do better, please come talk to one of us. I'm Will.
I'm Ben.
And I'm Prima.
Last but least. Here, I'll let you do this.
We are Full Stack Data Science is a part of Data Community DC, which has a few sponsors, including Rotational Labs, which you'll probably get to hear more about later during today's talk, but they're pretty cool. We're also here. Whoops. No.
Yeah, you can.
We'll skip that one for now.
Oh yeah.
The food and space tonight is provided graciously by a.k.a.
Thank you, fella.
I do work here for a.k.a. as one of our solutions architects. We are currently hiring, so if you want to help our clients build cool data solutions, I think we're looking for some machine learning engineers, regular software engineers, a few data scientists. If you specialize in Azure, definitely please come talk to me, because we've got a lot of both private sector and federal clients who are all about Microsoft, even if not all of us are quite as enthusiastic. So
let's see. We also have a wonderful Slack channel. If you want to take your phone, now's the chance. You can snap a little picture of this. I'll give you a second.
And how many people are new here? How many just first data meetup?
Great new faces. Thank you all for joining.
So if you are interested in staying out with people afterwards, the Slack workspace is a good way to do that.
The Meetup connections expire after 24 hours, so do not rely on Meetup. Rely on Slack. All right, I'll give everyone a chance to let's get this nice code here. And also, I'll say too, if you have your laptop still and you want to code along or anything, feel free to do that. If you want to connect to the Wi-Fi, it is a.k.a. guest. They'll prompt you for your cell phone number, and then you should be able to connect fine. Okay. All right. And we also want to promote some other excellent events upcoming. There's Civic Tech DC. This is the, I think, rebirth of the Code for DC meetups. They're an excellent sort of civic-oriented, project-based meetup. Power BI DC. I think if you like Power BI, I think go to that, I would say.
And that one on Thursday is going to be an especially fun one. It's really about data ops and agile practices for data and really any kind of data artifact. So it's not purely MLOps focused, but if you go to that and every time they say dashboard, think machine learning model, it'll still be a valuable talk. You've also got two options on Thursday.
Oh yeah.
That's the data science meetup.
Yeah.
It's also having an event, and they're always fun.
Yeah, especially if you're in the Maryland area and you don't always like to come out to Virginia, that's also a good option. The Women and Gender Expansive Coders Meetup. This is a sort of a rebirth from the Women to Code Meetup. This is a great, excellent group. We know the organizers well, and is a fully, welcoming thing. Anyone's welcome to come join that. The Data Engineer Lunch. Actually, I don't do you have any additional details about that?
Yeah, so they're having another virtual data engineering lunch Monday the 29th, and that's going to be on Remio, which is a company that does managed Apache Iceberg. So cool data lake stuff if you're more on the data lake side of things. And then
we have a little scoop here.
Yeah, so I'm giving another talk next Tuesday. This is going to be a webinar, so it's online. And the link is available on rotational.io. So do you sign up? It's at noon next Tuesday on how to build your own custom LLMs using Hugging Face. So it's not just be yet another ChatGPT wrapper. Also, if you can sign up even if you can make up, because then we'll send you the recording afterwards so you can watch it at your leisure.
Excellent. Well, I think, are you, yeah, please, if you want to help out at all, we always love an extra helping hand. So if you have any talks we want to give, or you have any friends or colleagues who have some great talks, great things they're passionate about, feel free to reach out to us. You can, like Prima and I, and Will, you can also help organize. We always love that too. And of course, please tell your friends, your family, your loved ones, your dogs about this great event, so we can have even more people coming. Yeah.
And if you have, crazy skills with like the dog memes on TikTok or I don't know how the kids do digital
Yeah.
stuff these days. But if you are good with digital stuff and wanted to say like help do live streaming next time,
Yes.
or help with promotion and outreach, that's cool too. But if not, you have a good time tonight. Tell a friend, bring a friend next time.
All right. Thank you so much. And I think here we go. I'm going to welcome to the stage. Is there one more? Oh yeah. Thank you. Yeah. Sorry. Of course. I think this will be very popular. Please, if we have any, if we're going to open the floor, if anyone has any announcements, if you have jobs to give, if you're looking for jobs, if you are organizing other meetups, have fun events coming up, please raise your hand and we'll let some people to the floor. This is an excellent place to introduce yourself to the group. I know for sure people here are looking for jobs. I checked something earlier, so if you're not too shy, I would recommend coming up and advertising yourself, saying what your skills are and what you're looking for, because there are definitely people here who have jobs to give.
Any fun events that we missed?
Do you want no pressure? No.
Yeah.
Okay. Well, no. Okay. Well, I know for a fact that there are people with jobs to give and people who are looking for jobs. So after this, please, mingle a bit and talk, because I know there are some sections to be made. Good. Well,
All
I
right.
think, and on to the next event. Talks. Or yes, or talk.
All right. All right. Hello, everyone. Thank you so much for attending today for today's talk on event-driven architecture and its surprising benefits for machine learning. So a little bit about me. I am Prima Roman. If you want to connect with me on LinkedIn, feel free to scan the QR code. So I am a senior machine learning engineer at Rotational Labs. So Rotational Labs is a AI consulting company, and what we do is we work with our clients to build custom large language models. So if you come to the webinar next week, if you attend that webinar next week, you'll get to kind of hear some of the things that you can do to build your own domain specific large language model that's tuned for your business needs in a way so that you don't have your proprietary data leaked to any sort of third-party service. We actually build it for you in your own environment. And we have several years of like data engineering and software engineering chops to be able to do all of that. I am also an adjunct professor at Georgetown University, and I like going on long walks around the DC area. So with that, let's begin the talk. So how many of you here have either built like a REST API that basically stands up a machine learning model that serves predictions, or have been on teams where the model that you developed is deployed into production and is used behind a REST API? Yeah, so it kind of figures like that's kind of tracks with like generally like how machine learning models are deployed into production in the form of an API that's then powers like a website. So typically, so REST APIs are sort of built on top of what's called the request response architecture. And so what that looks like is you typically have this like client application on the left, and it sends some data over to the server application, which is where the REST API, that hosts the REST API. So it'll take the data, it'll load up the model, run a prediction, and then send the prediction back to the client. And then the client, once it gets the prediction, it will serve this prediction usually on some website. It'll be like some user-facing portal, something along those lines. But kind of some of the things, some of the challenges that you had to deal with kind of this pattern is like, how do you deal with the server latency? So there are times when there's a lot of requests coming in and then the server gets bogged down. It might be, not as performant. It doesn't return responses as, quickly as you'd expect. You may also have use cases for the same data. As soon as it kind of arrives at your application, it needs to be sent both to a prediction service, in this case, to like runs kind of prediction, but also maybe that data is fed into some sort of a dashboard application at the same time. The other thing, of course, is that with REST APIs, like over time, you might have to make changes to your code and then you have to change your specifications. How do you deal with that? How do you let your consumers, of the API know, right? Like, so these are kinds of the things that, you all probably have dealt with. So to kind of talk a little bit more about these drawbacks, really at the end of the day, the main reason like why we have some of these challenges is because these applications are tightly coupled to each other. So the client application, typically like when it's submitting a request, it's blocked until the server sends a response back. So the idea of blocking, in software engineering terms is the fact that you have to wait until you get a response back before you can do anything. And so that inherently causes latency in the system. And then kind of like the API specification changes. So like if you roll out V2 of your API, now you have to tell all of your consumers to go and change your code to meet the new specification requirements. Sometimes you might have to do backwards compatibility and all sorts of things. And the larger your organization is, typically what that means is that the team that's built out this API is a completely different team, maybe in a completely different department, and you have no idea who all of your consumers are. Like it's, you might miss somebody, and then so really that means there's a lot more potential for miscommunication and failure. The other thing is that now there's a lot more use cases for streaming data, so data that's coming in constantly. So you have flight departure and flight arrival data or weather data. Like if any of you have lived in the DC area for long enough, know how in one day you can have like 4 different weather events. Try to do anything on that, like in a traditional request response, it can be a little bit challenging. Also, sometimes if you have applications that are on edge devices, or even just in general, if there's a network connectivity issues, if you send a request to a server and then the server for a reason like is down, how do you know, right? Like you might have a failure in your application, or vice versa. The server has sent a response back, and now you're in kind of like some dead zone, and how do you these are some of the challenges that you had to deal with. And so here, kind of present an alternative kind of architecture that you can leverage, and it has been around for some time. And so I'll kind of first present the textbook definition of event-driven architecture, and it's basically a software design pattern that allows systems to detect, process, manage, and react to real-time events as they happen. And so this is from the Confluent website. So Confluent is a company that manages Kafka. And so event-driven architectures have been around for some time. And I'm actually curious here in the audience, like how many of you have built applications using Kafka? So it looks like very few. So it's been around, but it's kind of slowly starting to gain steam. And so but there's a lot of potential there, especially with a lot of innovations that have happened in the last few years especially for the data analytics piece, and that's sort of like what I'm going to talk about today. I'm also curious if anybody has used any sort of other like event-driven architecture solutions like Google PubSub or AWS Kinesis, or anything similar. Which PubSub? Anyone else? So with PubSub, I'm curious, like have you used it in a way just to process data? Have you used it also in a way to like store data? So, but it's just really only about processing the data and,
yeah.
Okay. All right. So for those of you who are not familiar with event-driven architecture, like for me, like I know, like when I first read about it, it's like, what does that even mean? Like, I don't really understand what an event is. And so there's a lot of different definitions. And, as you mentioned with Google PubSub, you're just using it to process data. And in fact, I think one of the earliest kind of flavors of event-driven solutions, they only cared about processing data. It's just you get the data, you process it, and you don't care about actually persisting the data at all, because the whole point was to try to process data as quickly as possible and as much data as possible. So low latency, high throughput. But then I think over time, people kind of realized that we also we need to store this data and do something with it. And so there have been like, people will do things like you process the data, but then maybe store it in some other like solution, like a relational database or data lake or whatever, and then do something with it later. But then now you have to manage like two different systems, right? So it would be great, like if you could kind of have this event, tool that's used for processing data, but then also leverage it for doing, analytics. And so even Kafka is kind of like not, has, persistence. Now you have to turn on persistence, and oftentimes and then of course, if you're using it to kind of do, kind of quick, once you kind of turn persistence on, of course, it slows down applications. But the argument that I will make is that not every, like if you have a use case where it's more about just being able to handle things in a streaming fashion, but the speed doesn't matter. The persistence aspect of it actually gives you a lot more functionality, which, I'll kind of touch on a little bit. And then there's also like sort of like other use cases that I think this kind of opens up to that, if you're interested, you can kind of come and talk to me after, that we can discuss, because it's kind of like beyond the scope of this talk. But yeah, so the main idea here is that, I kind of want to take the solution and kind of take it into the context of data analytics and machine learning. So really, if you kind of think about what an event is, it's, one example is it's an update. So for example, if you're doing, buying things online and you add an item to your shopping cart, or you remove an item from a shopping cart, that's an event. Maybe you're changing prices. So if you're taking Uber, for example, depending on like if you're going to the same place, depending on the time of the day, the price changes. It can also mean an action. So it's, either like an order was purchased or an order was delivered. But really, at the end of the day, all an event is, it's a unit of data. So now I'll kind of, on a high level, talk about some of the main concepts within the event-driven architecture. There's a few others, but I think for simplicity's sake, for those who are not familiar, I'll kind of boil it down to like the most important components. So here on the left, you have a bunch of different publishers, and what they're doing, they're basically applications that are producing some data, and then they publish or they save this data to what's called a topic. And a topic is no different from like a table in a relational database. It's just the way that it's stored and the way that data kind of comes in and leaves the system is different. But it's really the idea of applications that create and write data into a data store. And then you have subscribers on the right-hand side that are actually reading from this topic and doing, something with it. And so I want to kind of take a step back here and kind of compare this to the request response framework. So if you kind of take the request response framework is sort of like the idea of, let's say you're interested in buying a magazine. So you go to a bookstore that sells the magazine, and you go to you go to you get the book, you go to the register, you pay for the book, and you get the magazine, you get the magazine back. And now what you had to do was that you actually had to physically go to the bookstore and get this magazine. Now, on the other hand, let's say you like this magazine a lot and you want to keep getting it, a subscription for it on a regular, basis without having to go to the bookstore every single time. That's where like, it's kind of like event-driven architecture, where you just set up the subscription one time. And then at some regular, cadence, you're going to get the magazine. So this sort of idea with subscribers is that they subscribe to a topic. So they have this kind of handshake agreement that, as soon as the data arrives in this topic, then I will, then the data will get pushed to my application. Like I don't actually have to go to some server and request the data. Like the data will kind of come to me. And what you also notice here is that the producers of the data and the consumers of the data are not actually talking to each other directly at all. They're actually decoupled. So that gives you those advantages of like, you don't have to worry about it doesn't really matter if any code changes happen here, as long as they're producing that data and just, writing it to this topic, the subscribers don't, they're not going to be impacted or depend, have any, they don't have to do anything. They're just, all they care about is like getting the data when, when it's available. So before I go further, does anybody have any questions?
Oh, so would you say that webhooks are a good example of event-driven architecture or not?
So I think that, so there's actually kind of different flavors of it, right? So I think that if I'm not mistaken, like webhooks sort of will do some like sort of data processing, but I don't think that there's a notion of like writing data to a topic and reading from a topic. So I think they're actually kind of like a different concept.
Thanks.
Anyone else? All right.
Downside.
What are the downsides? So it requires like understanding, so, and you'll kind of get into the code a little bit, but you have to like understand the async module. So a lot of the stuff like happens, asynchronously. And so there's like kind of some additional guardrails that you kind of have to put in order to like, since you're not waiting to like receive data, like you have to have some sort of like a framework around like getting acknowledgements. And then if you don't get the data as you expected, then there might be things that you have to do later to do some like retry logic to get the data. But it's, one of those things, it's like it's like a learning curve, but then once you actually get it, like there's once you kind of figure all of that stuff out, like it's actually gives you a lot more functionality than you otherwise would get with the request response architecture, because there's a lot more capabilities and a lot more flexibility with this architecture. All right. Okay, so now I want to kind of touch on the concept of a topic and compare and contrast it with a table in a relational database. So I figured I'll take the iris data because that's like the most commonly used data to kind of explain sort of machine learning concept. And so if you were to store iris data in a relational database, you would probably have something like an ID column that uniquely identifies each row. And you have the columns that identify each iris species, which are like the sepal length, sepal width, petal length, and petal width. And you have their corresponding values. And so what you're seeing here are like records that are stored vertically in a table. That's sort of like how it's represented. And I would just kind of flip that around and kind of the way events or the data are stored in a topic are kind of stored in a horizontal fashion where you have each row kind of coming one after the other. And so the idea here with some of the newer flavors of event-driven solutions is that, well, first of all, like they're always guaranteed that these events are stored in order. So like that was the other kind of benefits of like event-driven architectures, that the data goes in at the time at the time that it was created and inserted, and you don't have to worry about like things going out of order. So you could actually replay the tape. With the relational database, you don't actually have those guarantees. And then, so the other thing is that these events can be processed in real time or queried at a later point in time. So to, I think, answer Sean, your question, like one of the ways though, like in a real-time context, you may sometimes not be able to process or get access to data for whatever reason. But the thing is that if these events are stored in the topic, there's always like ways to kind of go back and like retrieve the data from the topic if need be. So there's at least like that kind of flexibility. And so these 2 points here, especially the fact that these topics can be stored, that store these data points in order, and the fact that you can also query them at a later point in time, actually opens up some other use cases, especially for machine learning, which is kind of beyond the scope of this talk. But if anybody's interested and curious, feel free to come after the talk, and I can share that with you. So here, let's take an example of like a kind of a hypothetical application using event-driven architecture. And so you can kind of see like how it can be a lot more flexible. So here, the application is sort of like, say you're a restaurant and you want to you have customers who come and eat at your restaurant, and you have like a application, like a website where customers can post reviews about their experience, and you want to be able to analyze this data to see like typically like what their whether the experience was good or not. And so we'll kind of build this sort of application that takes this customer review data. And so here you have on the left a customer review application. That's your publisher application that, you know, as a new customer review comes in, we'll publish this review data to this customer review topic. And here it's the one topic, but it actually can be read by multiple subscribers. So we actually have 2 subscriber applications here. Down below here is the customer review sentiment analysis application that has, you know, basically like a machine learning model. What that's going to do is like once a new customer review kind of data comes in, it will use the model to, you know, label like the sentiment, you know, of this review, whether it's positive or a negative review. And then it will pass this review and the sentiment information to this other topic, and we'll call this like a customer review sentiment analysis topic. And then you can feed this review and sentiment to like a customer support portal where the customer support representatives can kind of take a look at these reviews and, you know, kind of, you know, triage these and, you know, figure out like what kind of action to take. On the right side here, you know, we can also, you know, have this customer review analysis application that's ingesting this customer review data. And it will run maybe your typical like data analysis, you know, kind of thing, maybe do some sort of like aggregated statistics, or it could be even another machine learning application that's doing topic modeling or like keyword, like top keywords, just to see generally like what customers are saying. And that also can be fed into some other portal. I didn't actually put a topic in here, but you could have it also be, you know, publishing that to another topic and then do something with it as well. So you have kind of more flexibility here, you know, as you can see, you know, rather than having like, you know, multiple like applications calling the same API, you can just have them kind of subscribe to the same topic and then kind of do this in this like a real-time fashion. So any questions about the last 2 slides or any other questions? All right.
The benefits here would be that instead of having to make a bunch of different API calls to bring data together and do that ETL, if everything's already going through an event stream, you can just bring them, they're already together.
Yeah. All right. So now I'll just kind of summarize like sort of some of the advantages that you have for event-driven architecture. So as you notice, like these applications are now loosely coupled. They don't actually have to, the producers and the consumers of the data do not actually have to communicate directly with each other. So there's no dependency also on any kind of changes to the publisher code. And the subscribers are simply just listening on a topic. So they have to be online though, like when the data is getting published. But if they're not even online at the time, you can always go back and use the query feature to get the data from the topic at a later point in time. And also, this means that the subscribers can do other work, you know, while the data, you know, they don't actually have to sit there, you know, like send the request and like wait for the response. It's just kind of waiting for the data to kind of come to them. And so that's, you know, for some applications that actually kind of reduces the latency. And so because the idea of like data being streamed to a subscriber, this is actually much more suited for, you know, streaming data where data is kind of coming in constantly. And also, you know, as I mentioned, the fact that you have the ability to query data in the situations where network connectivity is an issue. The subscribers can read from that topic to kind of retrieve any data that they may have missed. All right. And so the last part of this is I'm going to kind of basically introduce you to Ensign, which is kind of like an alternate solution to Kafka. And it's also a streaming database platform, and it's designed for building stream processing applications and also streaming analytics solutions, because like unlike, you know, one of the drawbacks, you know, you mentioned like with Kafka is that you actually have to turn persistence on. And then you also think typically you can only store data for up to 2 weeks. We have persistence turned on by default because recognize like sort of like the importance of using this architecture for analytics solution. It's also a hosted solution, so you don't actually have to do all of the DevOps work, like where you have to set up Zookeeper and change all these YAML files and like have to figure out how much, you know, CPU, how much memory to allocate. You know, we take care of, you know, all of that for you. So you just pretty much like have to install one of the SDKs to interact with Ensign and you're good to go. So to get set up on Ensign, it's, you know, so these slides will be available on the Meetup site. But we have like kind of starter videos to kind of help you create an account and then, create a project and then generate API keys for your project. And then you create topics for your project. And then you can just kind of write code to, to work with the, project. So I'll just kind of show you real quick here. Let me actually just first log out. And so just, if you kind of come in, you log in, this is kind of like what the page will look like. And so there are these starter videos and you have the projects, and you have your team profile. We also have this called Ensign U, which is basically Ensign University. So you can have tutorials on how to use Ensign. We have what's called a data playground. So this is like a collection of like publicly available real-time data sources. So if you want to kind of play around with building these like real-time data solutions, you can use the data playground. So here's like an example of this is kind of like a list of projects. So for example, like I have this like sentiment analysis project and I created like a few different topics. And so I have this topic called Yelp data, which is what we're going to be using for the demo. And I also have a repository here. And so we'll kind of go over this, and the link to the repository is also on the slides. So the first thing I'm going to do is just kind of give you a high level of like some of the main functions, and then we'll go through this repository to kind of see how they're kind of put together. And then I will demo the application. And so basically this is kind of taking a much more simplified version of this. Like it's basically you have like a publisher application that that takes Yelp review data. So this is actually in a CSV file, but it'll kind of loop through the records in the CSV file, like as if it were a stream, and then publish the data into this topic. And then we have like a scorer like application that will read this review data and then load basically a DistilBERT model from Hugging Face. And so I've already done the training. So this model, will just do the prediction, on the review, and then we'll just kind of print out the review and the sentiment. And so with that, so the first thing I'll just kind of real quick, high level, like the things you can do is, so there's actually two SDKs that we have for Ensign. There's a Python SDK and a Go SDK. And I know like here we just use the Python SDK since, typically build machine learning applications in Python. And so basically to use PyEnsign, you just do pip install PyEnsign. And then let's say you have a topic called My Topic. The way it works is that you use to publish the data, you call this Ensign. So this is an Ensign client that's going to communicate with the Ensign server. And so use a function called publish. So it's ensign.publish. And then you pass in the topic name and then the event. And it's on the right-hand side, like once that event is published, you can subscribe, in real time. And we use this sort of like a asynchronous generator that will read data as it arrives. And so you use like async for event and ensign.subscribe, and you're subscribing to the topic. And this line is what does the handshake. And here we're just going to simply print the event. And then alternatively, here you can use SQL to query for the historical data. And so, for example, you can set up a cursor, and this is no different from the relational, or like where you create a cursor and you do cursor equals await ensign.query, and this is just querying everything from the topic. And then once you get the cursor, you're just looping through the cursor and printing the event, and you see the same there.
Is this ANSI standard SQL, or is it a specific SQL dialect like Postgres or something?
So it is NSQL, but so far, like, so it's a lot of it's going to look very similar to like the ANSI style of SQL. But yeah, it is also like the Ensign flavored SQL, and because I think all of that will probably, like, as we add more features, we'll probably have more functionality that makes it look like more like how you'd interact with the traditional database.
And most of the large like streaming systems do have their own sort of like SQL like query language. Are there any notable things that people should be aware of as they move from like SQL or Python to working in one of those?
You mean for like the other solutions or? Yeah, I know like Kafka's got KSQL. So I guess like in that case, like, yeah, like learning their syntax, like just using, um, because yeah, there's always those gotchas like where it's different. Um, flavors depending on especially the more complex you have to, you have to, more complex things you have to do. And, but yeah, but generally like, generally speaking, I think they tend to be similar. I think it's just more about like reading the documentation for, all of these different flavors. And then I think there's also a lot of like other solutions that are like built on top of Kafka where they kind of abstract that away for you too. So there's a lot of innovation in, in this space, because I think a lot of people recognize like the benefits of using this, the notion of having data that's coming in order to do some sort of like, real-time analytics, or even like in some kind of like historical analytics in a way that's easier than the way it has been in the past. Any other questions? All right, so now we'll kind of do a little bit of a deeper dive on those functions that I just showed you. But before we do that, like the first step you have to do is like initialize the Ensign client. And so when you get the API keys, for your project, you'll get the Ensign client ID and the Ensign client secret. And generally, like the best practices is to store them as environment variables in your operating systems rather than passing them, directly, especially if you're going to put this on a GitHub repo somewhere. You don't want to actually put the credential right there. And the client is smart enough to know, like, if you haven't passed the credentials, it'll actually just look for it in your operating system. And so just the way to do that is you'll have call this like export. You can either put in your bash profile, or just if you're just using it temporarily, like you can do export Ensign client ID equals and then pass in your client ID. Similarly, export, Ensign client secret, and you pass in the client secret. And so to initialize, you do this import, from pyensign.ensign import ensign, and then like I've created a class that's called self.ensign equals ensign, and notice that I'm not passing anything here, so it'll just read from the operating system and initialize this client. All right, so now we'll kind of take a deeper dive into like the actual public publish function. So Ensign uses the async IO module, since, mentioned earlier, since there's no direct, you're not actually synchronizing on, you're not coupling like applications together. You're kind of these applications are working like asynchronously. You use the async IO module, and when you have a function that's asynchronous, you have to add this async keyword before the function definition. So in this case, you're calling this function publish. So you have async def publish. And then the idea of like to create an event, in this example that I'm showing, and it'll be also the same kind of idea in the repo, is you have a dictionary object. You convert the dictionary object to JSON, and then encode that JSON into a string, and then the MIME, and you specify the MIME type. In this case, is application JSON. And so we support a number of different MIME types. Like it can be text plain, it can also be pandas, data frames, or pickle objects. But this, so this particular one, we're just streaming all of this data as JSON. And so we'll create this event. And so it's event equals, and then event is a Ensign data structure. It's like a container in which like you can hold this data. And so you're converting this dictionary object to JSON by doing JSON.dumps record, and then uses .encode UTF-8 to convert this JSON into a string, and then specify the MIME type equals application/JSON. And so, yeah. So it's really like a data type, right? I mean, I know like people, this is why like I was like, when it took me some time to understand like what they meant by an event, right? Like at the end of the day, like I think people just want to like come up with like some complicated terms to like explain something that's really very simple. I have no idea the origin behind that name, but that's exactly like what I would think of.
Like a video or an audio, you actually have to tell it which kind of MIME type you had to associate it with the file. It was a big thing.
But why call it MIME? Like when it's really such a really.
That part I don't know.
Nail? Mail? So the event has a internet mail extension.
So actually, that's. So one of the reasons like why you do want to specify the MIME type, and this is like one of the things, because the fact that these are like not coupled applications, you actually have to know how to parse this data, right? So that's why like you have to specify the MIME type. And the same thing like when you're consuming anything from the internet,
It
right?
also doesn't hurt to know that you're actually talking about the same thing.
Right, exactly. Because like I was expecting JSON, but this is, I don't know what this is, right? Yeah, so we support that too if you want to use it. So, but yeah, so now we'll actually call the publish function on the Ensign client. And so here we have to use this keyword called await. So the idea here is that because this is an asynchronous function, you're not actually waiting to get anything back. You have to use this await keyword. And so here you do await self.ensign.publish. You pass in the topic name, you pass in that event that you just created. And then, so here, when you're talking to the server and you don't know, like what happens on the server side is that when the event actually gets published into the topic, it'll send you an acknowledgement, an ACK, to let you know that this event was committed. So even like the relational database world, like, when you commit a transaction, it's the same idea. Once it's actually stored in the topic, is the commit. It'll send you an ACK. And these are optional parameters that you can do. Like, so when you do get an ACK, like do some function. So you could log the acknowledgement, maybe pass it on to something else, some other application that needs to do something with it. There's also, of course, in the case like where the server tried to store the event and something happened, it will send you a NAC. So that's like, oh, something went wrong kind of thing. So then you have a parameter here to handle NACs as well. So similarly with the subscribe, you use the async keyword before the function definition. And then, so in this case, like, events can kind of trickle down anytime. You use a for loop, an asynchronous generator to capture this event. And so this is actually going to be running indefinitely. So it's like an indefinite like for loop that's going to do process an event as it arrives. Is it what? I think it's actually, and so you use this async for event in self.ensign.subscribe and you pass in the topic name. And then once you do receive this event, then in this application, you're going to call a function called self.generate predictions. And that also is another asynchronous function. And so you use the await keyword before the function call, and then you pass in that event. So now it'll take that event, it will load the model, and then it will run the get the prediction for that event.
I presume that there's a way to unsubscribe from the topic, right?
Well, so you in the application, the way you subscribe is dot subscribe, but then if you no longer want to read, you could close down your application or like so that's like one way. Like the subscribe thing is really like when you're actually running your application live, it's going to be subscribing. So which is why, like, I think I also mentioned, and you'll see in the demo, like I'll actually run the subscriber first, because if you're not online yet and the publishers publish the data, then you don't get.
Well, like, let's say I'm making SBA on one of the screens that has, for example, real-time flight information. And let's say I can transition between that screen and another screen. And that's the screen of the real-time flight information is subscribed to somewhere. If I am looking at the other screen, my concern is that if you subscribe to the previous screen, I want to be able to unsubscribe that to be able to view those resources.
You would then have to kind of like read. I mean, the only way you can actually unsubscribe is essentially you have to exit out of the application, right? Like you can't. I mean, that's kind of like true, like no matter like which, for any sort of application, right? Like if you don't want it to do like what you expect, you want to make some changes, you'll have to like make the changes to the code before.
But my primary concern though is that means, first of all, we are subscribed to a topic by default, even if we don't have that screen open. And then if that's not the case, if we subscribe when that screen loads, then the problem is that every single time that screen loads, we have to resubscribe unless we have some sort of global context. I think.
So you have some kind of application that is being, some kind of dashboard that's updating based on like the data that you receive from some topic, and then you no longer wanted to
Yeah,
update.
exactly.
Um,
I'm a Rust developer, so this checks out.
So I think at least for web applications, the way, and please let everyone chime in if you have better ideas. The way that I've typically seen things like this done is you would have the web server subscribing to the event stream, let's say getting all the flight data from, from your aircraft, from your flight systems, and, putting all that into that event stream. And then you'd have the actual, the front end of the web page talking to the server.
and then so maybe update the server code. I mean, so I think that's sort of like what I was saying was that if you no longer we wanted to be updating that dashboard, then you have to update that server code that's going to be reading from that topic.
Well, just a follow-up question to that. So basically, you choose a REST endpoint, the UI in front of it, so that would be kind of like a, and then that would subscribe to this. I don't know.
You could do that for like potentially a WebSocket or something. depending
Yeah,
on-
so you can WebSockets is a way to, yeah.
For from the machine learning side, one thing that is increasingly popular, so I might be stealing your thunder, is having that machine learning model where the inference of like the training data is coming in continuously through an event stream, but then those predictions may be served via conventional REST API. Interesting.
So that's actually that's a whole other talk, because there's also like a notion of like real-time machine learning, or what they call online machine learning, which unfortunately I think that was a bad term, which is why I don't think it's taken off, but there's been a lot of development in that space for a long time. But that's actually also another really great use case for these streaming platforms, because what you're basically doing is you're training the model on the fly, and it's updating its parameters and weights with new data as it comes in. And a lot of the big companies are already using it right now, but it's just not talked about as much, and it's harder for like, you do have to have some like specialized knowledge in terms of like using these streaming platforms in order to be able to do it effectively, and it's harder for smaller companies, which is I think another reason like why we developed Ensign, because like you don't have to worry about like some of this other stuff like in spinning up like these like real-time streaming platforms. You can kind of build these applications without having to learn like all of this other complicated DevOps work. But yeah, that's a whole another talk in terms of like bringing in data real time and having models update on the fly, and then serving predictions.
Does he have the ability to detect like duplicates, for example?
So, I mean, so you could have something that actually detects the duplicates. I will say this. Unfortunately, we had, so because you have the ability to store these events in the topic, one of the features that we had tried to roll out was this automated deduplication, where if you specify the deduplication policy, it would do the deduplication for you. Like, so for you later on, when you're querying at a later point in time, because you would think that a database would already have this functionality, like it should be part of a database offering, but we have to do all of that work ourselves. And so we did build that feature. Unfortunately, it kind of had some hiccups, and we haven't yet, haven't had chance to like fix that problem. But once that feature is released and is working, as I can, definitely use it. But the idea there is that if you set the policy on the topic beforehand, it will take care of it for you. And then when you're querying, you're guaranteed non-duplicate data.
When it comes to deduplication and event streams, you get to a really, really, really fun area of what do you mean, you want at least once.
There's that too.
And you start getting into real questions of interesting, almost philosophical questions of what is a duplicate event?
Which, yes, which is why like in our case, but so our use cases for people who are not, who don't necessarily care about the data in real time, but what they do care about is the ordering of events and want to be able to like retrieve it at a later point in time or be able to replay the tape. And so if you, and then if deduplicated data is really important to you, like if we, we have sort of the machinery under the hood, it just needs to, like some bugs need to be fixed, basically. But it, once that functionality is available, it could be, really useful for a lot of applications. But yeah, so the idea of the replaying the tape, and I might as well like give a little bit of a, the fact that you have events stored in order. Now, in theory, like when you are training models, you could store the offsets, like, of your event stream as to like which data that you train your model on. So if you ever wanted to go back and, maybe try a V2 version of the model on the same data set, you have a easy way to figure out which data that the old model was trained on, and then you do kind of like model, like you'd have to kind of build this yourself, but you have ways to version control your models and version control the data, for your models.
I've run into issues where data scientists train models with data from the future, or rather.
Oh, yes, yes, the data leakage problem, yes.
Where they're, in a like a relational database setup, you may have some event that happens later on, say like customers going and buying something. There may be some data that shows up after they've checked out, like in say the delivery phase. And if you're not being very careful, it's easy to intentionally or unintentionally bring that data into your training data. And then when you go to actually build something for inference, you won't have that feature, which may either totally break the model or just reduce the predictability.
Right. Yeah, that's like the student that only cheated, got the test before taking the test. So it's a very common problem. And so this is something that an event architecture would solve, because these events are in order, basically like what was already stored, you kind of can prevent those kinds of things from happening. Any other questions? I thought I saw a hand raised. Okay, so now we'll do just a real brief code walkthrough. And so this is the repo. So I have kind of like two Python files here. The trainer part has, you can kind of take a look at it, just shows you like how to download the DistilBERT model from Hugging Face and train the data, on some like Yelp review data. The score is what I'll kind of walk you through. And so the score is actually composed of two different applications. There's the application that's going to publish the data to a topic, and then the application that's going to read from this topic and create a prediction. And so a couple of imports here of note is, we're importing the async IO module, and then from pyensign.events we'll import event. That's the data structure, the container that I was talking about, and then import the ensign client. And so here, for the function that we're going to use, like when the acknowledgements or the NACs come from the server, we're just going to simply print the acknowledgement. And so here we're just going to print the timestamp of when the event was committed. And then here we'll just print that we could not commit this event, and kind of like the error code, so like why this event did not get committed. So to initialize this, so there's the score data publisher. And so we'll pass in this Yelp data topic, that I showed you earlier. And then we'll set the topic, and then we'll initialize the instant client. And here I set an interval. And this is only actually specific to this particular application, because you're sort of simulating a real-time data stream, but it's not really real-time. And so what's actually going to happen here is it's going to loop through all the records in the CSV file. Thank you. All right. Let's see. Oh, yeah. So after it loops through all the records in the CSV file, this application will exit. The problem is that it's still like going and like committing these events. And so what we want to do is like make sure it doesn't exit prematurely. And so this interval is just like adding a sleep to this program before it exits, so that all the data gets published into the topic. And so here with the publish function, all we're doing is just reading the CSV file, as a data frame, and then we convert all the data frame records to dictionary objects. And, as mentioned earlier, we'll loop through each of the records and then create this event, and then publish this event. So just, and then after that's done, we'll sleep for 1 second, and then that's the end of the publisher. And so really this is pretty much like all you have to do is just to kind of simulate like a very basic, publishing function. And then here we have the score. So here we'll pass in again the topic. We'll pass in the directory where the model's stored. So we'll set the topic, set the model directory, initialize the Ensign client, and then we'll load the model and get that ready to make predictions. Oh, and then I forgot to mention, so this is actually common in both of the functions. Since this is going to be like a forever running application, what you have to do is create an event loop, and then you call this function called run until complete, and then you have to give it the name of the function that you're going to run indefinitely. So in this case, it's asyncio.get event loop .run until complete, and then the self.subscribe. So in the publisher, it's self.publish. And so you can then look at this subscribe function. And so as I mentioned earlier, this is an asynchronous generator. So you have async for event and self.ensign.subscribe, pass in the topic name, and then we will take the data out of the event. So that and we know that this was a JSON object, we'll do JSON.loads event.data. So the event has actually more than just the data, but what we need is the data part of the event. And then call this function self.generate predictions data. And all that's doing is it's going to take that data and then pass in that classifier model, and then it will print out the prediction, it'll print out the text, it'll print out the prediction, the confidence level of that prediction, and then the actual label. So this data happens to have the label, so you can see how well the model did. And so I just basically, since you're both in the same function, you pass in either score data to run the publisher or score for the scorer. So now I'll just do a real quick demo. So here's where I'm going to, let me just kind of clear this out. So we'll run the subscriber application first. I'm just using CPU, so that's why it's actually giving me this little message. And then here's the publisher, and so you'll see the events got, that's the timestamp on the top. The events got committed, and then here you see it. For each of those records, you can see like the review. And so you can see, yeah, some of these are kind of interesting. But you have the prediction here, and then you have the label at the end. but yeah.
It was probably true.
So that's pretty much the demo in a nutshell. And so, yeah, so if you're interested in building an event-driven application, try out our sandbox. It's completely free to use, and, create your account. And I mentioned Ensign U earlier. And then we also have the data playground if you want to experiment with real-time data sources. And it is in beta, it's kind of really, you could definitely use help with either, contributions even, or if you have questions, also any feedback, we're, definitely looking for that. And so, all right.
Do you have the intent of doing a TypeScript API at some point?
We have thought about it, but we will need, it'll probably be sometime in the future, but we definitely would like to do something in JavaScript or TypeScript, because it sort of makes sense to have this in front of like a web application.
When it comes to even the way the async and the asynchronous nature of this, and Node.js might actually, I think that should be based on top of Node.js.
Yeah, I think they're all kind of that whole flavor of JavaScript, TypeScript, Node, the same family. Yeah.
Since Node.js is, I think it's based on Google V8 engine, and, it's already asynchronous, and
Mhm.
I think it's also faster than Python. And that makes sense to me. Really, really.
Yeah, and in fact, like, so there's now, I think there's a lot of people in the JavaScript community who have actually also built machine learning libraries, and it's actually entirely like possible to do a lot of this stuff in JavaScript as well. Alright.
Yeah, so for that demo that you just showed us, that was using Ensign. And so it was streaming the data from that CSV
To the Ensign server.
to the Ensign server, and then also opening up a separate subscriber.
Yeah.
Or so you opened up the subscriber, listening to the server to that topic,
Hmm.
and then you were streaming data to the server.
Hmm.
And it seemed like it was coming back really fast. And you
Mhm.
mentioned that like that was so fast, I got confused. I thought it was all local for a second.
Yeah, it actually did go to the server, and then you had this the subscriber that's actually getting the data is getting pushed to it, and then running the predictions.
Earlier, you had mentioned that streaming often had lower latency
Mhm.
compared to like REST APIs. Could you quantify that? Seems super fast. Could you quantify that latency compared to say if you had been doing it via REST API? Like what kind of range are we looking at?
I've actually never done that specific comparison for an application like this because there's definitely a lot of different factors to it. But it would be interesting, like if I were to like build an API to do this prediction to see like how, what the difference would have been.
So going back to the comparison of APIs versus event-driven framework here. When you have let's say, a data change, right, or schema changes, you have a API version 1, version 2. Let's say here your input data changes, you're adding your feature, your highest data, for example. What does that mean? Does it mean you have to update now your queue, or does it mean you have to create a new topic every time you have a new feature? What is that?
So yeah, actually, that actually is one thing that can, is something that you have to account for. We do have a way to specify the an event schema and a version as well. So if you do wind up like having, that kind of thing, like where you want to use the same topic, but you want to kind of change the data specifications, then that would be, then in that case, you can use the schema parameter for the event and the version to be able to then at least like before that time, like you have the topics, like, so it'll be like metadata, right? So then you can, when you're querying, you have all the data that was using a previous schema, and then going forward, you have this new schema. But yeah, in that case, that does involve some communication, and have to let your end users know that the schema has changed and there's a new version of the schema. But at least like that at least removes the other part of like, because oftentimes when code changes, it's because the data's changed too, right? So at least you at least eliminated one thing from the equation. So you could do it either way, but we have functionality where you can still use the same topic and just change the schema, like change the schema and change the version. So it's the so when you say queue like the same stream. Yeah, so I think in that case, most likely what's going to happen is that the publisher probably, you would have to probably do some kind of like temporary like maintenance window or something, close it, because I think that's the only way you could actually publish if you want to reuse the same topic or just have a different topic. Mhm. Yeah, so both options exist. So I would say the two distinctions is like, one is you don't need to do all the DevOps work of like standing up the instances, like that's all, it's a hosted solution, so you don't have to worry about any of that. The second is that we kind of call ourselves sort of like the Toyota, Honda, like of the streaming world. Like we're not the fastest. If you're asking for like something that's going to be high with the lowest latency, you're not going to get that, because especially if you've turned on persistence, like the minute you turn on indefinite persistence, like it's going to be slower. And but we are reliable, like we guarantee the order that the events are going to be in order. You don't have to worry about any of that. So yeah, so those are probably like my two. to like compare and send to Kafka.
So how do you dynamic schema?
With dynamic schema,
Yes.
I don't know how. I don't know if I've heard of dynamic schema. Does any? I mean,
So the data has and it doesn't have specific schema, then it would be the schema would be updated as a data type. That's dynamic schema.
but then you're storing that, like that's like a storage solution, though, right? That's not really, but you're not really processing it.
It's unstructured data, so the data when it's loaded, but it would have something structured based on the dynamic schema. What it does is it picks the schema based on the data that's being.
Oh, that's interesting. I had to look that up because I actually had no idea. Yeah, perhaps I think that sounds like a talk idea there, actually. Uh-huh.
It's asynchronously, so it's cost efficient, it's energy efficient, all that. I don't think that's true. The same computation happens. It's just that.
Yeah.
Imagine that as some overhead.
Yeah, you know what
Energy perspective,
Mhm.
back.
You know, I have to agree with you on some of that, like with all of these like different ways that they say that they do bring in their own overhead. Like one of the things that I've been, in the last few years, I've been trying to do some kind of like optimization problems for like data crunching. And every time I've tried to use the multiprocessing for what my specific use cases, never gives me the kind of speed promises that they say it can, because the kind of problems that I'm doing, like it's taking something to data and then it needs to transform it, and I still need that data. So there's a lot of overhead behind serialization and deserialization, which actually makes it slower than like,
There was a great paper several years ago called Cost Configuration That Outperforms a Single Thread. They were looking at a multiprocessing framework similar to Spark, and they found that with that overhead of, especially once you have to get to a full network and you're getting away from multiple, you're getting to multiple computers, there they found that we need sometimes hundreds of CPU cores to go faster than a single CPU core. That's
wow.
Of course, the flip side of that is if you have more data than a single CPU core can ever process, you have to.
That's the only reason like you need, like I think like all these like multiple computers, otherwise, yeah. And then but the other problem also is like when you do have like say distribute all this stuff, then you also have to worry about IO and all of these other things, right? And then
So when is event-driven architecture probably not a good idea? Yeah.
You're too many, maybe too often, right? Synchronous or the opposite of whatever that. Space probes. Yeah.
like actually also like especially if you're streaming things, but you really want to do computation on a batch of data, then it doesn't make sense to use an event-driven, architecture, because it's really meant to process like one record at a time.
I'm doing overnight batch job and doing machine learning on all the finance stuff before we send it out to a customer.
Mhm.
That might not be a good place for.
Yeah, because you need all of that data to do some kind of computation on it, right? So then, yeah, it's not really meant for that. Now you could have, once you have this event store and you wanted to like then query and like, but then at the end, then you're still going to be doing some kind of like batch processing. Right? You're just using that store to do. So, yeah. Mhm.
I'm sure they have like event bus, they have like service bus, event hub, because they have a file queue. How do you compare with others? Are you cheaper or more performant?
Well, we are free. Um, so basically this is like, just to try it out, it's free, but if you wanted to kind of build some sort of like enterprise application on your own cloud, on your own VPC, then you kind of do we would then, kind of do kind of like a service contract. But yeah, otherwise, like, part of it's also like we want to kind of put this out there for people to use and experiment with, so that we can kind of build all the, the bells and whistles, and then really, oftentimes I think what happens is, yeah, like people will have like some really complex use cases for which they want to use something like this, and then they would kind of, reach out to us to help, setting this, infrastructure up.
I just had a question on the otter iconography. Is there
Ah.
is there a reason for that?
Yeah, I do get this question actually. So the term for like a group of otters is raft. And so raft is like the algorithms, the distributed systems algorithm. So our CEO has a PhD on distributed systems. So that is sort of like kind of the genesis of this otter idea.
In that same vein,
Mhm.
all of the task queues that exist have the weirdest names. Rabbits, Kafka, Ensign. What is?
Oh, well, Ensign actually came from when the product idea came a couple of years ago, or the team, this was before I joined. But we're in Salt Lake City, Utah, and I think there's a place called Ensign Peak. And I think that's sort of like where the idea came from. They're like, oh, let's call it Ensign to kind of mark the place where we came up with the name, like the Right? Any other questions? All right. All right. Thank you, everyone.
Prima, thank you very much. That was an awesome talk. Very cool. So I'm gonna go ahead and shut down the live stream. So thanks everyone for joining us. Thank you, live stream.
Thank you. Have a good night.